Approximately 5 billion gallons of stormwater flow across the Albuquerque metropolitan area every year through a complex drainage system, carrying pet waste, garbage, sediment, chemicals, and trash into the Rio Grande. Local agencies responsible for stormwater management comprise the front line in the battle to minimize this pollution, but they only capture a fraction of what goes into the river. This is the story of how every citizen must join the battle to reduce that pollution and help keep the Rio Grande.
The importance of trying to protect stormwater from pollution is because the Rio Grande ecosystem is impacted at each storm event when a surge of different kinds of pollutants enter the river and shock the system. So we want to make sure we minimize that shock at each storm event. A partnership has been formed between the City of Albuquerque, AMAFCA, Bernalillo County, the University of New Mexico, Ciudad Soil and Water Conservation District, the Highway Department, and SCAFCA, which is like the Rio Rancho area version of AMAFCA, to try to do public education and outreach on what we can all do ourselves to help keep the Rio Grande, and that's our motto. The University of New Mexico has great involvement in helping keep the Rio Grande. On our academic side, departments such as biology, engineering, water resources program, earth and planetary sciences, even the law school and their Utton Center are actively involved. This is the headwaters of the North Diversion Channel. This channel drains about 100 square miles of the city of Albuquerque, coming off the west side of the Sandia Mountains. It's the largest drainage that feeds into the Rio Grande with stormwater. As you can see here, it is a challenge to keep all the debris and litter picked up off the streets, whether it's City of Albuquerque or University of New Mexico. But we do the best job that we can, try to stay ahead of the storm.
Welcome to the North Diversion Channel. Carries 44,000 CFS, approximately 30 feet deep at this point. And at any time it rains, we could have approximately 10 to 15 foot of water above my head. The water that's in this channel ends up heading into the Rio Grande. The North Diversion Channel is the last chance to try to capture anything before it gets into the river, and it captures a lot of debris and trash from the urban area. I have pulled out car parts, couches, laundry baskets, shopping carts, wrecked cars, dead animal carcasses, and one wedding dress. So we're trying very hard to provide water quality before it enters this system.
You're looking up the North Pino Arroyo. And at this location, we divert some of the water from the North Pino through a pipe, and that pipe discharges to this facility. This is the North Pino Stormwater Quality Treatment Facility. It's basically two facilities in one. We have primary treatment, which is what this facility is here. And then further downstream, we have secondary treatment in the form of a pond. What this pond does is it takes water that has been somewhat cleaned up in the primary facility, meaning that we've taken out the tumbleweeds, the litter, and quite a bit of the heavier sediment. And we've diverted that water to this pond where more of the sediment will settle out. From the rays of the sun, the ultraviolet rays also help us clarify the water with regard to bacteria. From here, the water is diverted over to the North Pino Arroyo, which is right to my left here. And about 200 yards from here, it is discharged into the North Diversion Channel.
We're standing here along the north side of westbound I-40, looking west toward the West Central Interchange. We're looking at a project here that was recently constructed by the Department of Transportation in coordination with AMAFCA. When we design projects, we not only look at the roadway, but we also take into account the drainage features, the storm drainage, and how we are going to handle the rainwater that we receive in this area. We are standing on a closed drainage system which carries flows from up near the Rio Puerco and out to the north, carries those waters down in a closed system. These are what we call flap gates. The intent of these flap gates is to allow pressurized flows to push the gates open, enter into the pond, removing trash and debris, allowing that to settle out in the pond. The inverted pipes that you see here do not flow horizontally into the box. You can see that they flow up at an angle, which prevents the trash from entering the box once the pond gets full. The water is allowed to flow in, however, the trash stays in the pond and again is removed by maintenance workers. One of the district's core maintenance activities is roadway sweeping. Over the years, this operation has increased significantly. To date, our employees sweep 80 hours a week. This not only improves the safety and appearance of our roadside, but it also has a positive impact on the quality of our stormwater. Over the past 5 months, we've collected 2.9 million pounds of debris off of our roadways.
Well-managed stormwater is a significant contributor to the verdant scene you see at Sanchez Farms today. This is one of several stormwater management facilities owned and operated by the County of Bernalillo. Sanchez Farms is the most advanced stormwater treatment facility that we have. Stormwater leaving the Sanchez Farm neighborhood first enters this facility where sediment is removed and floating contaminants are removed. From this facility, it's discharged into the wet meadow and wetlands on its way to the pump station. Here we have the managed wetlands at the south end of the Sanchez Farms facility. It's different than the wet meadow at the north end from the standpoint of which kind of vegetation grows and the amount of water in the soil. Both clean stormwater extremely well. Perhaps the constructed wetlands is more efficient than the wet meadow, but they're both very good at removing pollutants from stormwater. After the pollutants are removed by natural vegetative action, we have a bar screen in the rear there entering the pump station where any remaining floatables will be removed before the stormwater is discharged to the Rio Grande.
Since 2003, the Bernalillo County Commission has appropriated $100,000 a year to improve stormwater quality. Extensive street sweeping activity in the north and south valleys removes approximately 1,150 cubic yards of trash and debris each year.
Beyond the wet meadow, we have a community farm. It's also the overflow for larger storm events. This is the outdoor classroom facility here at Sanchez Farms that is used by La Placita, the management entity for Sanchez Farms, as well as schools and the county open space to deliver environmental education and farming education to the public. This is just one of the many multifaceted, multicultural uses of this county-owned stormwater management facility.
We're here at the Bareilles Pump Station, one of the city's 14 pump stations in the Low Valley around downtown and North Valley. Its primary purpose is to be flood control, but one of its other purposes is it collects trash. I see plastic bottles, paper cups, fast food containers, lots of plastic bags, beer cans, cup of noodles, sagebrush, leaves, all sorts of paper containers, a lot of plastic. There's some styrofoam, and this is just a week's supply. This is the wet well of the Bareilles Pump Station and contains the pipe where water enters into the system. And that water is filled with trash, which gets collected by this bar screen. There's a series of arms made out of metal that lift the trash along the screen up to the top, where they then dump it over the top of the bar screen, and it's picked up by the conveyor belt and dumped into the dumpster, and we remove that. During the rainy season, we may have pickups of that dumpster multiple times a week. The history of stormwater pollution begins in the 1970s when the public asked the government to become involved in reducing or eliminating pollution coming from factories that were along waterways. The municipal separate storm sewer system came out of that in the 1990s. The MS4 system was designed to look at non-point source pollution, like that which came off of cities. And here in Albuquerque, we have 188 square miles of urban area that can contribute to non-point source pollution into the Rio Grande, which is defined as waters of the U.S. and is the responsibility of the federal government, protected by the Environmental Protection Agency.
I'm standing in the Sportsplex Dam water quality facility right now. This facility was constructed in 2007 on the Montoyas Arroyo. The Montoyas Arroyo is the largest arroyo running through the Skafka jurisdiction. It drains about 60 square miles of watershed. This water quality facility collects what's referred to as the first flush, which is the stormwater quality volume. It's something less than the ultimate volume in a rainstorm. This pond actually intercepts all of the runoff coming down the Montoyas Arroyo, and it actually stores that water temporarily to allow sediment and trash and floatable debris to be collected here prior to being discharged downstream in the Montoyas Arroyo. This water quality facility is immediately adjacent to a relatively new residential neighborhood. That neighborhood has a storm drain system that feeds to this pipe outfall here into the water quality facility. Anything from the neighborhood that is picked up in the streets in the stormwater ultimately gets to this facility. We get a lot of construction debris in our facilities because of the amount of construction in this area. We've got an assortment of things here that are obviously from the neighborhood, whether it be tennis balls, baseballs, shoes, toys, or of course the drinking bottles. Runoff collects in this water quality pond here first, and it's temporarily stored here, and that allows for the sediment and the floatable debris and trash to actually collect here. The trash and debris that actually floats into this facility is prevented from moving further downstream by that concrete box structure at the end of the water quality facility. That box structure is perforated with holes that actually allow water to pass through, but not floatable debris or trash. We have an operations and maintenance group that comes in and actually removes all of this trash and debris and then disposes of it properly.
I represent Ciudad Soil and Water Conservation District. We do a wide variety of things. Basically, the programs that we follow are set by either the New Mexico Department of Agriculture or the USDA. And primarily they're attempts to keep the watershed clean. Around 2005, it became apparent that the Albuquerque area needed an entity to write what EPA calls a watershed restoration action strategy. The Rio Grande, unfortunately, is listed by the EPA as polluted. What they're asking is, what is the state of the problem? What are the watersheds involved? What are the specific things that people in the watershed or the natural watershed itself are doing to contribute to pollution? And then specific ideas for how to clean up stormwater. We're on the banks of the Rio Grande here, a little bit upstream of the Alameda Bridge. Over there is Corrales. We're about an eighth of a mile, maybe a little more, downstream of where the North Diversion Channel comes in. And we're about a mile upstream of the intake structure for the new drinking water project. So we're putting some of this trash into the river right upstream of where we're taking it out. And we're putting all of our stormwater from the Northeast Heights into the river there. It goes down the river, it gets picked up by the intake structure. This innocuous but nasty little piece of litter may have actually been tossed out somewhere up by tramway. It's a good testimony to what we're doing to the river. We need to be more careful. And we need a system in place that eliminates that pollution.
In spite of the extraordinary efforts of the stormwater quality team, only a fraction of the pollution is removed from the system. It's an elaborate and expensive process that should be regarded as a last-ditch effort rather than the solution to the problem. It's our river, our water, and our pollution. We need to ask ourselves one basic question.
When you drop something on the street, think about how you're going to drink that. I think that's the take-home message here.